So yeah, my name is Sebastian Witalec. So he already gave away half the information about me. I work as a developer advocate for Progress. If any of you is on Twitter, you can follow me. I'm Seba Vita, which is basically the first 4 letters of my first name and last name, easy to remember. So I just want to start with the first thing, just for any of you that doesn't know what's NativeScript, is basically an open source framework that allows you to build mobile applications using JavaScript. And you could use Angular, you can use Vue, or you could use just plain JavaScript or TypeScript. And then as a result, you get a mobile application with native UI. Okay, so that's pretty much all you have to remember. And yeah, it works for iOS and Android. Okay, so the goal for today of my talk is how do we achieve this scenario where we can have one project that gives us Android, gives us iOS, and a web application. Okay. So for me, the secret sauce is this combination of using NativeScript and Angular as one thing. So NativeScript gives us access to iOS and Android development, and Angular itself gives us basically ability to build web applications. Okay, but also Angular gives us like code sharing friendly architecture that allows us to actually achieve this goal. So let's kind of have a look at some of the items of Angular. So I'm not sure if all of you is familiar with it. So one of the things is the data binding mechanism in Angular, right? It's just basically the syntax that you use to communicate between your template, which is what you see like on the page, and the data inside your component or any actions that are within a component. So for example, we have a set of property bindings that allows us to basically hide away the communication between the DOM and your Angular components. So this is how we actually use a property binding to display a value and then pass it on to the DOM. And then also there is a set of event bindings. So if you click on an item or I don't know, slide or do any of the other events, then you can use the brackets to call a specific function. And then with this one, which is called by us banana in the box, which is how you actually do two-way binding. So that's a combination of the property binding and event binding. And the really cool thing is that it's just basically a standard that works pretty well for you, and you don't even have to think about what really happens on the DOM side. Okay? And then the other thing is actually how the render is structured in Angular. So we have basically our component, our template, and the render has a set of functions. This is not the full list, but there's a bunch of them. And then basically the template and component, they're connected with each other implicitly, and they talk to the renderer. Okay? So in the case of, let's say, we want to create an element, Angular will hide this away from us or take care of it for us. So when we try to create a component, the renderer will go and then execute a specific command on DOM to create that HTML component for us, and then return that element to us in Angular, so that we always kind of work with the element. And then automatically, as a result, we will get something in a web browser, right? And then obviously, the renderer implements all those functions for pretty much all type of components. So that's how it's done for the web out of the box. But this was actually the opportunity for us at the NativeScript team to kind of say like, wait a moment, what if we take this renderer and then just replace it with our own renderer? So at the time when Angular, what some people call Angular 2 came out, we kind of said like, this is actually a perfect match for us. So we already had a renderer that was working on iOS and Android. We just basically had to put it and make it work with these functions. So in this case, we basically found a way that we could implement create element that would perform something on the mobile UI layer. And then this would return a native element. And then as a result, we could get a mobile application. So the whole thing is like, okay, so all that templates and property binding and event binding that's available to us right now out of the box. We just have to take care of the renderer, plus a couple of other things. But this is what it is in a nutshell. So we pretty much look at a scenario. This is a component in Angular, right? So I call it my component for the lack of a better name. And the component has my name and my Twitter handle. Okay? Also, the component has a function, say hello. So if I call it with anybody's name, then basically we say hi, anybody. Okay, so this is my component, and then property binding for web, I could use, for example, double mustache to bind the name and Twitter to display those values. But also when somebody clicks on the button, I will call the say hello and say hello web, right? So this is how I do on a web application. In NativeScript, I could use pretty much the same thing. So the difference here is that we use different HTML tags. However, in that case, for example, when you have the first label, I can bind to the text property, and then I can print the name value, again to a Twitter value, and then when I have a button, instead of click, I'm actually binding to a tab event, but I'm also calling say hello mobile. And you see, like, the important actually part is, like, let's just compare this part. Binding to the events with just the rounded brackets and me calling function, this is just the difference is the name of the event. But the syntax and the way we achieve that is exactly the same way. And then another thing is, I only have really just one component implementation because it works for both approaches, which is the beauty of it. The next thing that is very important for the code sharing story is dependency injection. So basically, dependency injection is an ability to take a certain type of service, and then rather than passing, like, you inside your component say, hey, I want to create this service so that I can do so and so, you can actually do it at the root of your project. So whenever you want to get that service, your like Angular engine by itself already knows, like, oh yeah, we have that. How about I give it to you? And I'll explain why is this important is this moment. When I want to make some sort of HTTP calls, either on a web application or a mobile application, in order to call some web service to, let's say, get a list of cities, right, that you guys might want to visit, or countries that you visited, right? And the problem is that the syntax or the API for HTTP on mobile is different to the one on the web. But in reality, we should be calling exactly, the same functions to, let's say, get list of countries or get list of countries visited and dates, etc., whatever dates. So what we can use the dependency injection for is basically when we start a web application, passing the HTTP module for web, and when we do it for NativeScript, we pass in the other one. So I'll show you a quick example. So in Angular, there's the concept of ng modules. So those are responsible for managing the resources for your module or your component. So in the case of a web application, we will pass the HTTP client module, and then we pass in imports so that my web application knows where is the module that can perform the HTTP calls the web way, and that's the client. For NativeScript, we actually just have NativeScript HTTP client module. So underneath, it performs the operation in slightly different ways, but it exposes exactly the same API. So if I can use basically these two HTTP modules. And then in my actual application, when I have my service that can take care of the data, what I do is I'm just importing HTTP client from Angular Common HTTP. And this is the same client for both web and mobile. It implements the same API. And then in my constructor, you see I'm using dependency injection. So in here I'm saying private HTTP client. So here is the moment where Angular goes, okay, so you want the HTTP client. And if I'm in a web project, it will give me the NativeScript HTTP client module. The HTTP client module. If I'm in the NativeScript project, it will give me the NativeScript one. Right? So, but me as a developer that works on this specific service, I don't really care. Right? And then as a result, if I have a function that calls get data, I can literally just call this.http.get, and I don't worry whether this is going to work with NativeScript or web or whichever approach we take in at the time. So this is very, very powerful because I can really isolate myself of what is the target at the moment when I'm writing the service. Cool. So let's get into the actual code sharing and what are the sort of the approaches. There's few approaches, but I want to talk to you about one specific approach, and that's basically I call the monorepo or the shared project structure. So the monorepo project is basically where you have your web and mobile files in one place. Okay. So in this case, for example, if you know Angular, we'll have a bunch of pipes, services, directive navigation, and so all the white boxes are the shared ones, the blue is the NativeScript, the red is web, okay? And the idea is that we would have all those, for example, the data services that can pass the data for us or allows us to work with the HTTP. It will be completely shared. We could also share SAS variables if you want to manage the themes for our web and mobile applications, but then we would actually have two separate CSSs for web or mobile. Then our components. So the TypeScript class, this is where our business logic of the component sits. However, the HTML code will be split into two separate files. So we'll have a web HTML and a NativeScript HTML. And then obviously with modules, the modules, they can combine a bunch of components underneath. The modules also can manage navigation, etc. So what components and what navigation you use within the modules, they're all shared. It's pretty much the same code. But then ng module for each of those modules will be a separate file. And then once we have this project structured like this, what we need is some sort of build process that allows us to take this and then convert it into application. So the build process, if we're trying to build a web application, should be able to take all the white and red boxes and then run, let's say, Angular CLI to build an application for us. Or if you want to build a mobile application, take white and blue boxes and give us a NativeScript application. That's kind of the approach we're going for. So that was pretty much in theory. And so how do we do it in practice? So one of the approaches, which is pretty popular at the moment, there's this seed project that is available on GitHub that you can just clone and use it as a basis for your project. And that's done by the guys from Team Maestro. It's called Angular Native Seed. I recommend, check it out. And I'll later do a demo that is based on this specific project. And the way this specific project works is if you have your project inside the monorepo project over there, to build a web application is business as usual. You just call ng-serve, and then this will trigger Angular CLI tools, and which will give you a web application. If you want to build a mobile application using this monorepo project, then in this case, we're going to call npm run iOS or npm run Android, and this will work in two steps. So the first step, it runs gulp, and gulp basically goes like, oh, let me find all the blue boxes and convert them into white boxes. So it kind of recreates the project, like the NativeScript project, ignoring all the red boxes. Okay, and once we have the NativeScript project, the second step is this npm run command script. So if we have our component, so for our TypeScript class that is shared, we will have, for example, name.component.ts, and then we will have two HTML files. So the web one will be name.component.html. The NativeScript one will have the .tns.html. So this .tns is how we actually separate web from mobile. If you want to add styling and have two different CSS files, then you have, let's say, SAS file for web and then .tns.sas for the mobile. And to be honest, if you added additional file which would be called name.component.tns.ts there, then you could even split these two into separate. There might be a case where you might need that. But that's kind of like the idea. Obviously, this kind of leads you to a place where you have to create a lot of files to do that. So I created a small tool that you can use with NativeScript CLI. So it's an extension. So if you call install NativeScript Angular CLI, this will allow you to generate already shared components or generate shared modules. So it will generate all those files and kind of put like the hello world pieces in there, so they're pretty much ready for you to go. So it does pretty much what Angular CLI does for you. And that works specifically for the Team Maestro project. There's also some challenges that you need to look into when you do code sharing, because there's a lot of problems. So the first time I gave this talk, that was like an hour and a half session. So this is really trimmed down version of it. So one of the big challenges is kind of how do you deal with different versions of APIs? So I wanted to create a I wanted to create a demo project that was using that was using Firebase. And then on web, I was using Angular Fire 2. For NativeScript, there's a NativeScript Firebase plugin. And in theory, it all sounded pretty easy, right? It's like, okay, Firebase, easy. I've done it on web before. I've done it on NativeScript. The things I forgot, some small differences in the way the API is structured here and there. So the moment when I started trying to implement those, like the guys that implemented these two libraries had completely different concepts of how they should be done. So Angular Fire was done with observables. The NativeScript one was done with what was it? With just basic listeners. So the whole architecture was completely different. So a solution to that, one of the solutions to this kind of problems is when you have two different APIs, you could, for example, create a common service abstraction. So for example, if you're looking at a plugin that has 20 different commands, but you only need 2 of them to put them in your services. So what you can do is actually create 2 versions of your service. So let's say you have your data.service.ts and data.service.tns.ts, right? These 2 files. And then inside those, you would implement the same logic twice, but calling these 2 different APIs. However, you would expose them under one common interface. So they'll both have exactly the same type of commands. So that your components could just call directly those services. It's not super reusable because it will always be very specific to your Angular services that you're using for that application. The other approach, which I actually took in my project, is when you could do an abstraction on top of your plugins, not services, but plugins. So in this case, you have both your plugins, and then you create like a web plugin wrapper and a NativeScript plugin wrapper, which they provide the same common interface, right? So if you have like 20 different functions in each of those, you basically make sure that they both return the same thing, and those wrappers take care of the differences. So what I did in my case is basically I took all the listeners and I converted them into observables. It's pretty simple stuff as well. And then as a result, you can just create one data service that uses your wrappers, and then that communicates with your components. And then additionally, I can actually take these wrappers and drop into any other project that I use code sharing with Firebase. So I'm gonna do a quick demo. So let's see how it works. So you can also check it, so it's on my GitHub, so at sebavita/petbros. So it's a pretty serious application. So before I even show you the code, I'm gonna just run it. So I'm gonna run the web application, and I'm gonna run the NativeScript one. So npm run iOS. Okay. So the web app is about to come up. Why is it not coming up yet? There we are. By the way, I am not a designer, so do not, oh, come on. I mean, give me some credit, right? No, seriously, yeah, you can see that. The thing is that I actually used Angular materials, so it is not a complete disaster. So it's kind of decent-ish. So this demo project is based on, in the US, they have this service called Pet Finder. So all the shelters in the US, they advertise the pets that they have. And then you could use Pet Finder API to find animals that you would want to adopt. So there's like a bunch of animals. So basically on my homepage, I have all my favorite animals that I selected. And oh, somebody already adopted Ulysses. Interesting. All right, let's make a search. So I can go, let's say, in Boston, and then I can search for a small and furry animal. Any age, let's find a young one. Then I can go find pets. So the duck is a default picture if there's no pictures, but you could adopt Marshmallow. There's Cosmo and Brooke, Donatello. That's a serious stuff. Let's find some, yeah, Flash and Pumpkin. They're pretty cute. We can add them to favorites. What else did we have there? Why is it slow? And then maybe you can add Kalishi. And you could pretty much like search for any other animals, you know. Christmas coming, you can search for pigs to adopt, right? It's a bit slow. Or maybe there's no pigs in Boston. We can definitely find horses. There you go. So we can add Reina. So if I go back to home, yeah, Reina is here. So in the meantime, my mobile application built as well. So I'm actually starting with a login screen. And you could probably even notice that I even decided to have different type of navigation. But what's behind the navigation routes and etc. is pretty much the same. I'm using the same Firebase instance. I can see the same animal, so you can see Peaches there, Mr. Snake, Rhino's here, so I can click and then get some information and read on the horse itself. And then I could also use the search functionality, so I could search for cats, because why not? I'm not a cats person, but hey, Mark is okay. Let's add him, and he should appear. He's over here. So basically I have the same application for web and mobile, like side by side, that are based on the same code. He looks vicious. I don't trust him. Go away. So let me show you the code now, the interesting part. So one of the first things that we have, I'm gonna kill the build process. So one of the first things that we have is the navigation itself. So I'm using authentication guard. So if you're not logged in, you always automatically get navigated back to the login page. If you're logged in, then automatically will push you to the home page, even if you come back to the website. Additionally, like I have my navigation. So if I want to navigate to home, it will use lazy loading to load the home module. Or for my pet search page, again, I navigate pet search. It will go and lazy load all the components required to show my pet search page, etc., etc. So I'm pretty much using just one set of navigation itself. When it comes to my services, where are we? I've got my user service. So my user service is pretty much the place where that allows me to sign in or register or log out my user. I can also use it to kind of say, go and get me my existing favorite pets, or if I'm adding a pet to my favorites, then basically I can use my observable to kind of push it into that object, which automatically sends it to Firebase. So if we just consider on that, so I have my sign-in function and maybe log out and register. So that's just one service that works for both web and mobile. And then if I go, for example, to my login component, so in here I'm using again dependency injection to get the user service. And once I have this user service, I expose a login function, a register function, and a logout function that basically use the user service to perform those operations. And then when I'm looking, for example, at the HTML itself, let's start with NativeScript. So I'll have a couple of buttons. So one button on tap event will go and call login, and then pass in some parameters in order for me to validate whether it's okay to call it. And then another on tap event we call the register. We also bind to, for example, the password item, or we can bind to email. Where is email? There we go. So I'm using ng model to bind to email. The other, obviously, when we hear then the HTML for actually the web application, so I'll have, for example, a button that can call register. So that register will go and then automatically check whether we valid, but it calls exactly the same function. And then if I find the other click event, it also calls login in exactly the same way. So I didn't have to implement my component twice, just the HTML twice. And then also in my input form, so when I have my input field for password, which is required, and it's I'm again using the ng model to bind to the password or the email value. So the only real difference is in this case is the HTML, but my component, my services, they're all kind of the same. And I also have a wrapper around my Firebase, but I don't want to get into that too much because that was a bit of code. There we are. So I actually create a whole bunch of wrappers and then I expose them pretty much as an Angular module. So inside my Angular module, which is the core for web and for mobile, I'm just importing my Firebase ng module, which does the abstraction for me. So that's kind of the example project. I would definitely recommend you to check it on GitHub to kind of see the code, and you can always ping me on Twitter. But I have a few more slides I want to go through, and maybe another small demo I want to show you. So obviously that's kind of the way we've been doing code sharing so far, but we have some pretty ambitious plans to push it a lot further. So around mid-March, which is pretty much around now, and we already have some results. The real target for us is to have everything ready for ngconf. So I'm going to talk about what we're going to have by then. So we created a new shared project template. So the Team Maestro one, we're going to replace it with a new one, and that's going to be managed by our team directly. And it's going to be very similar to the Team Maestro seat, but there will be some differences. So at the moment, I didn't show you that this time, but you remember when I mentioned that we were running gulp to recreate the project in a separate folder. That's not going to be happening anymore. We're not going to use gulp at all. We, at the moment, with the Team Maestro one, we had 2 separate node modules and 2 separate package JSONs. So you kind of had to manage your dependencies separately, which wasn't great. And then this is going to be supported by NativeScript. So with the new project, we'll have just one node modules, and we will be using Webpack to do code splitting, and also we'll be using Webpack and tree shaking, so that if there's an npm module that we need in web but not in NativeScript, we're only going to use it in web but not NativeScript. But you could pretty much install all of them in one place. The really cool thing is that if you, let's say, updating your Angular version from 5.2 to 6.0 RC, like is the current version, you do it just once and then you update it for both web and mobile, right? So it's really, really cool. So some of the things that we're working on, so at the moment, so TNS is basically the extension for NativeScript CLI. So we're looking at plans where if you call something like TNS create my app --ng-shared, that will create you straight away a shared project with the name of my app. And if you go into that project, you can basically run TNS run iOS or Android to build a NativeScript app, or call ng-serve to build a web application. And I'm going to show you how that actually works in a moment. Obviously, we're doing some implementation to Webpack build, how it works. So the Webpack is going to work with LiveSync. So you all know, like, Webpack can take quite a while sometimes. It can be a minute or 2, depending on the size of the project. So we've added LiveSync support. So rather than waiting for a minute, it's like a second or 2 to kick off the refreshes. So it's pretty smooth and pretty sweet. Also, if you don't like .tns extension, you'll be able to change it to whichever you want. And also, you'll be able to add your own extension to web files. Maybe you don't want to have home.component.ts. Maybe you want to have home.component.web.ts for web files and .tns for mobile. So that's definitely configurable. We won't use gulp anymore. And we're also looking at integration with Angular CLI directly. So far, we've always been using NativeScript CLI, but for me, my vision is that you should be able to do everything just using Angular CLI. So if you feel at home building websites using Angular CLI, so should you with NativeScript. That's pretty much what we were heading for. So we're looking at things like, and this is already possible right now today. You could, for example, use ng-generate or ngg and then run ng-generate components or module, etc. And we have overridden how you generate a component and module, because they're slightly different for NativeScript, but so basically those generators take care of it. But then pipes, services, or any other things, they work exactly the same. And then this is pretty much possible thanks to Schematics. How many of you actually played with Schematics so far? You have to play with Schematics. It's not just an Angular thing. It's pretty amazing. It's a tool that allows you to do scaffolding or generate files in a really easy way. I'll probably show you an example in a second. So the other things that we're working on, and I already have half of the journey done, is project migration. So it's all good if I tell you here's a project that you can use as a template and you can build from scratch your web and mobile application. But then you say like, what about my existing project, right? It's like, I've been working in 6 months. There has to be a way to migrate it, okay? So this is what I've been working on recently. So there's a scenario. Imagine you, 6 months ago, you run ng new my app to create a web application. What I'm saying is that you should be able to call, let's say, TNS add mobile, and then this will run a special schematic that would take your web project and then convert it into a code sharing project. So at the box, it's not going to convert all the components or modules, but it will recreate, redo the structure of the project so that you could actually be able to call either ngserve or TNS run. Okay, that's the idea. Or vice versa, if you created before a NativeScript project and you want to convert to a code sharing project, you should be able to run just TNS add web and then ngserve and then TNS run. So this part of the story I already finished, and now we work in the migration from web to mobile. The other part is, so once you converted the project structure, then you could one by one start converting your components and your modules. So if you have an existing component, you could run something like TNS convert component home. So my home component, we're converting it, and then this will go and then basically move these files and then create the additional ones for you. So those will be still pretty empty. So you still have to re-implement what goes exactly into HTML and into your SAS files, but at least like the managing of the files will be done for you automatically. And then if you have a module that has a lot of components inside, you could, for example, run TNS convert module menu or the name of it, and then we'll recreate all your components, then move on your roots and your common bits, and then split your modules. So there will still be a little bit of work where we actually say what actually happens when those HTML files generate, but the structure will be handled for you, which is very, very powerful. And this has potential for more. So recently, so we're working with the Angular team to be able to actually create NativeScript projects directly from ng CLI. So at the moment, there is a schematics called NativeScript schematic. So you could actually already do it where you could say ng new my app, and then you could say add NativeScript schematic, and then this will actually create you a NativeScript project using Angular CLI. But we're looking whether we could actually have something like --mobile as a flag. Angular CLI, they just added a new command, which is really cool. It's called ng-add. So ng-add is basically something that allows you to transform your project to add additional bits to it. So you have a project and you say you want to add Mobix, which requires to install it and then maybe do some structuring of your project, right? So you technically, if the guys from the Mobix create a schematic for it, you would be able to call something like ng-add Mobix. And that's what I'm working on. So that migration process that I was talking about, it will really should work by calling ng-add mobile, and then this will convert your web project into a code sharing project. It's just a matter of a couple of weeks until we have it ready. And then also within that, we're looking whether we could actually do the conversion of the modules and the components like we're talking about. And also we look into a way, so if you heard about Architect, which is a kind of a way of structuring build process within Angular CLI, which is actually not even specific to Angular CLI, they just happen to use it there. We're working with using Architect so that you could actually call ngserve --mobile, and then this will use Angular CLI to perform the build process of mobile applications for you out of the box. So pretty strong ambitions, but we give ourselves a couple of weeks and it should be there. Wow, maybe not the Architect part, that would take 4 weeks. So some resources, that's a pretty long link, but if you Google my name and code sharing, there's like a really lengthy blog post that I created. It has a lot of pictures of Garfield, so if you love Garfield, I recommend it. Or if you want to learn about code sharing. I gave a pretty nice talk on it, so if you search for NativeScript Dev Day and my name, you can find additional talks where I go in more depth also. What else? Yeah, the extension I was talking about, NativeScript CLI, that's on GitHub, and you have like a couple of other projects that you can look into. So my Pet Bros project, and there's another one that is actually supported by my company. So it's NG2 dashboard. So that uses even like a Kendo UI library for the website, and then NativeScript for the mobile application. So it's worth checking it out. So yeah, thanks for listening.